Great. Well, thank you for coming to see this, and we're happy to talk about the importance of concrete in addressing climate change. This is a major field that I work in, and my co-speakers, Chris Nadel and Mayor Armacost, have been very active on the policy side of this. So I myself am an associate professor at New Jersey Institute of Technology, and I study concrete. I research the chemistry and the structure behind concrete and how we can make it more sustainable. And I've recently gotten more into the policy side and how we can implement that. And that's how I've teamed up with Chris and Mayor Armacost. And so I'll let them provide introductions when they get to their parts of the slide. But what I really want to focus on first is giving a background of concrete so that you have a good understanding of why climate change and concrete are so interrelated. So if you think of concrete like a cookie, you can start to use that as your analogy for how concrete is made and built. So a chocolate chip cookie has eggs and flour and butter, right? And those are the glue and the binder that hold all the parts of the cookie together. You've got sugar and chocolate chips. Those are the filler and flavor. And then you have modifiers like baking powder, baking soda, and salt. Concrete is very similar. You have cement and water, which are the binder, sand and gravel, which fill in the space between that binder, and then chemical admixtures, which can help to modify all sorts of properties of concrete. So just like a chocolate chip cookie, you can have your basic cookie or your basic concrete mixture that is the same all over the place. But with a cookie, you can change all of those things out. You can use M&Ms, you can use nuts, you can make a chocolate cookie, right? Concrete is the same way. There are infinite combinations of the basic materials that we use to make concrete that will get us to the right strength and the right properties. But some of them are more environmentally friendly than others. Some of them have more embodied carbon than others. And so there are 5 basic components that make up concrete. You've got air, hydraulic cement, water, and sand and gravel. Hydraulic cement makes up only about 7 to 15% of the concrete by weight, but it is kind of the outsourcing or the main source of carbon dioxide in concrete. And so we'll talk about that in a second, but concrete really produces a large amount of CO2. About 8% of our total CO2 output, man-made CO2 output per year, is because of the amount of concrete we make. And so we cast almost 2 cubic yards per person per year. And so even though on a unit volume basis, 1 bit of concrete has a much lower embodied carbon than, say, 1 bit of steel, because we make so much more concrete than steel each year, it has an outsized impact. So why is concrete associated with all of that CO2? Again, the main part of that that's producing CO2 is the cement. And so when we make Portland cement, we use a large rotary kiln like what you see on the screen, though this is much smaller than it is in reality. In reality, this is about the length of a football field. And so we put the raw materials in the top, they slowly move down to the bottom, and they get heated up to about 1400 degrees Celsius. And at the end, we produce clinker, which is what we produce Portland cement from. And so, of course, we have to heat that system up. So that uses quite a bit of fuel. Generally, we're using non-renewable resources like coal and oil and gas, but we're also looking at waste sources. But whatever we burn, we're producing CO2 by burning that to get that temperature up. However, this only accounts for about 40% of the total amount of CO2 that comes from cement production. The rest of it really comes from this process known as calcination. So calcination is the process that happens when we break down calcium carbonate or limestone with heat. So limestone is a main component of making cement. And when we heat it up, we produce calcium oxide, or CaO, and carbon dioxide. That calcium oxide is one of the things that helps cement bind things together once it mixes with water. But that CO2 is really released into the air right now. We don't have very good ways of capturing it at the moment. There's a lot of new technology that is coming on the market, but it is not quite there yet, and it's going to be fairly expensive to implement. And so this isn't, so there aren't really immediate solutions to reducing the embodied carbon of concrete just by collecting that CO2. And also you still have the fuel burning that is going to add to that. So what can we do to reduce that CO2? How can we make ourselves some green concrete, right? And so obviously when I'm talking about green concrete, I'm not talking about concrete that is just dyed green, but concrete that is more sustainable, that has lower embodied carbon. The main way we can do this is by trying to cut out as much of that hydraulic cement or Portland cement as we can. There are a number of things that we can do to replace that we call cementitious materials. So things that work like cements or bind with the cement that's in the system, but aren't the same material that we normally put in. So this includes things like ground up limestone, though the amount we can use of that is fairly low, about 10 to 15%. We have what we call supplementary cementitious materials. The common ones that are very active in use right now are fly ash, which is a byproduct of coal burning, slag, which is a byproduct of the steel making industry, and silica fume, which is a byproduct of the microchip making industry. These have been really great for concrete to help to reduce the overall embodied carbon, but as our coal burning goes away and our steel making becomes cleaner, the sources of these become less available. And that's a good thing, right? We don't want to burn coal. We don't want to have very dirty processes for making steel, but that leaves us searching for new supplementary cementitious materials. Unfortunately, there are new ones coming onto the market. One that is particularly important for the New York area is ground glass pozzolan. This is produced by crushing up to a fine powder waste glass, and then calcined clays, which are just your everyday clay that is heated up a little bit, not quite as much as cement, that can become reactive. The great thing about almost all of these is that they tend to have a fairly moderate cost, so you can make concrete at just about the same cost with these new materials as you could with just straight Portland cement. And a lot of them are already familiar to contractors because they've been used heavily for achieving really specific properties with concrete prior to now, but now we're looking at using them as a source of reducing embodied carbon. I did mention that ground glass pozzolan was important to our region. This is something there's a new source of this ground glass pozzolan being created in Western Connecticut. It's using waste glass from upstate New York. You can see in that picture on the right, this really is waste glass. You've got a Heineken bottle cap in there that gets cleaned out. And then that gets crushed down to that fine white powder on the bottom. And you can mix that in with cement and you get concrete with really very similar strengths and durability. We're doing quite a bit of research with this material here at NJIT right now. And it's really an up and coming thing for our market, which is great because we're really losing access to some of those older materials. Another up and coming technology is incorporating carbon dioxide into the mixture. So there are a couple of companies that sort of are running this, CarbonCure and Solidia Technologies. And in these systems, you're actually mixing carbon dioxide right into the concrete. So with CarbonCure, they basically freeze carbon dioxide and mix the frozen flakes into the concrete. Solidia Technologies cures the concrete or stores the concrete as it's gaining strength in a special place that sort of saturates the system with CO2. And by doing that, you actually increase the strength of your concrete. So if you're looking for concrete of a similar strength to what you can make with Portland cement, without this technology, you can actually reduce the amount of cement that you have in your system. And so this is some really interesting new technologies that are coming out, and hopefully they gain some more traction in the future. But right now, unfortunately, there's just limited availability because it takes special equipment and concrete contractors that are bought into this technology. And so hopefully that comes out a little bit more. So we talked a little bit about the fact now that we can do this, right? We have the technology, we have the resources. What is stopping us? Why are we not making all of our concrete as green as possible? Well, there's a number of things that go into this. One is there's a very real fear of cost, right? Most of the concrete that is produced as purchased by the state or municipalities or the federal government, and they of course have a duty to get low cost for those elements. And when we start looking at new technologies, those costs can go up. Fortunately, a lot of these technologies really do not increase the cost of concrete. Some of them may increase the right upfront cost, but you get very good long-term gains because the concrete is more durable, depending on the technology. But there is plenty of evidence that you're not really increasing all of your costs quite significantly with this. Knowledge transfer, I am an academic. I sit here and I read journal articles all day that are, stuffy and nobody else wants to read. I get it. We need to do a better job of getting this information out of our research labs and into engineers' hands, into cities and towns and states, to get them to understand how they work better, and make sure that everybody understands the safety that is inherent in these and how well they work. Space and capital, this is a very real problem, particularly in urban regions. If you think about a concrete plant in New York City, it's basically a postage stamp size plot of land. They only have space for so many different materials. And so trying to introduce new materials requires some startup capital to buy some more land, to build a new silo, to bring those new technologies in. And for smaller companies, that can just be overwhelming right up front. And so finding ways to offset that will really help to improve that, the growth of these technologies. And risk. There is always a concern with new technologies, especially in construction, about liability and risk. What if something breaks, right? Fortunately, we have a lot of data that shows that these materials really perform as well as or better than our standard concrete. And so, there really isn't a lot of risk there. And the main risk that we can't measure well in the lab is how well it's going to perform over 75 years, right? Not necessarily that it's not going to be able to handle a normal load, but is it going to degrade faster or not? We have test methods that measure that, but they accelerate everything. They're not the most accurate, right? And we just don't have 50, 60 years of field data with some of these new materials. And so there is a little bit of risk associated with that, but I think that's true for most green technology. Fortunately, most of this can be overcome with political will, right? Getting the right policies in place to sort of get us through all of those issues and really give people the comfort of knowing that the cost is right, that the liability is taken care of, that there's time and space for people to learn new technologies. That can really help to overcome all of those barriers. And so there have been a number of sustainable concrete construction policies put in place around the country. they vary from sort of very targeted resolutions like what you have in Austin, where they say we really want everybody to start using this carbon cure technology where we input CO2 into the system, to much broader things like what's happening in Hastings, which Mayor Armacost is going to talk about, to requirements like what we have from the from Marin County in California that kind of dictate what you can and cannot include in your concrete and how much global warming potential you can have in any new concrete mixture. New York State is really one of the groups, one of the places that the lead is happening here. And I'm going to pass this over to Chris Neidl, who's going to talk about what's been happening in New York specifically.
Great. Well, thanks, Matt. Pleasure to be here. Great to be here with you, Matt and Ben and Mayor Armacost. As a group, this is probably the third or fourth time we've done this. We've really been working away at what was before a pretty obscure policy area, but really just in the last couple of years. And Matt, your perspective on this would be interesting. It's really been elevated, I think, where it's become more of a sort of a common and active area of policy, both at the local level and at the state level, and now at the federal level as well. So it's very exciting. New York, as Matt just alluded to, what I do I'm the co-founder of the Open Air Collective, which is a climate action network, but I'm also a policy advocate for the Natural Resources Defense Council, and I work primarily on state policies focused on the decarbonization of concrete. And looking across the country and what's happening in different states, like Matt just referenced, there is a lot going on, but New York really does stand out, I think, at this point of doing some really novel, interesting things and really taking a lead. One policy area that I worked on very closely that Matt was an advisor to, and Mayor Armacost was familiar with as well, is the Low Embodied Carbon Concrete Leadership Act, or LECLA. And this was a bill, a version of it passed earlier this year, was signed into law. And this requires the state to really come up with a plan for how it's going to procure low carbon concrete, considering particular policy mechanisms that we proposed in it. So that was a victory, and versions of that bill have spread from New York to several other states at this point, but really starting here in New York. A huge thing that happened this last Earth Day is the state, as part of its already existing green procurement executive order, which has been around for a dozen years or so, has all sorts of different materials that requires environmental considerations to be taken into account when the state purchases it. They added concrete, which was massive because it's a very complex material. It's been a very difficult thing to come up with rules for specification for reducing carbon and other environmental impacts. But they did, after a very long and robust process, generated a pretty excellent specification. And so this basically requires all state agencies, when they're buying concrete, they have to follow this specification, which is designed to reduce cement along the lines of what Matt was just talking about, to lower that carbon footprint. And that's really, Matt could speak to this, but I don't know if actually there's another state that has a lower carbon concrete specification, actually. So it really is a first and something that can be replicated by other states. But what's important, as Mayor Armacost knows, is that many local governments actually depend on the state's specifications for concrete because they've been tested, they've been approved. So they tend to follow the state specification. So with this change, that kind of liberates, or I think gives confidence to local governments to start to also make these changes as well. So it has a real ripple effect. And again, as Matt referenced, it's the public sector buys the vast majority of, is the largest single purchaser of concrete in the country. And a lot of that is state governments. The New York State will be the single largest purchaser of concrete. So if they start making these changes to their specification and purchasing decisions, that also has a ripple effect really into the private sector as well. And then even before that, and I know this is something that Matt was a advisor to, is the Port Authority of New York and New Jersey, really very exceptional among authorities of its kind across the country. I first heard about it, I think 3 years ago, or 2 or 3 years ago, was when they first announced their intent to come up with a low carbon procurement practices to align with their long-term climate and net zero goals. And last year they came out as well with a low carbon concrete program that focuses on cement reduction for their own procurement as well. So just a lot happening in this area that is pretty unique that we're already seeing influencing other states and also really having an influence on federal government choices too. So that's something for us to be proud on and to continuously build on here in the state. I think next slide. One thing I did want to point out, I was the co-author with Professor Caleb Woodall, who was previously at Columbia, but for the Natural Resources Defense Council. We had looked around to all the different policies that are being considered or implemented in different states and by local governments concerning low carbon concrete, and came up with a guide to best practices or model policies. In that guide, I can pop it in the link and it can be shared with the recording, but it's a good breakdown of the different types of policies that can be put in place and combined to maximize the impact that both state and local governments can have. Highly readable and really designed for staff, people who actually work within state and city agencies. It's very practical. So recommend people who are interested in the subject and particularly in decision-making positions to give a look at that guide. My contact information is included in there. So feel free to reach out if you have any questions. Great. Well, I think with this, I am going to hand it off to Mayor Armacost, who's going to walk through what Hastings has done. And let me just set this up a little bit. As Matt had said, and we always say, all concrete is local. It literally, as a material, it has to be produced locally and used locally. And local governments have a lot of discretion over policy and the decisions that they're going to make as purchasers. And when we were trying to push the ball up the hill around the state policy, it was so important that Mayor Armacost and Hastings really saw the need for this, and that it was in line and consistent with their already very ambitious and impressive local policies around climate mitigation. And Mayor Armacost really took this on and understood the value of it and started pushing for a resolution to lower carbon in concrete, and then immediately looking at actual projects within the village that could utilize it. And by doing that, when we were advocating for it at the state level to make it less abstract and to demystify it, we were really able to point to what Hastings was doing as a real example within the state. And that made it a lot more real. And I know that it's influenced not only other local communities in the Hudson Valley, but has gotten a lot of looks from peers, cities, and villages outside of New York State as well. So I just want to emphasize how important those local decisions are. They're often the first on the scene, and they have a really important effect at inspiring change at both horizontally and vertically at other levels of government. And that was certainly the case with the Hastings resolution. So with that, Mayor Armacost, did you want to give the story of the resolution?
Sure. Thank you so much. And thanks to you, Chris. You've been an amazing ally from the very beginning. And Matt, who has educated us all about the scientific background to what we are asking for in the context of this resolution. I want to start by saying that a lot of our work on the resolution really came about through the work that Chris had done with the Open Air Collective. He was being very modest about the various hats he wears, but there was this group called the Open Air Collective that was very interested, and maybe Chris can talk to this a little bit more later because they're doing other interesting work, but they were the ones who had begun this work on the importance of concrete because of all of the reasons that Matt has outlined before from an environmental point of view. And so at the very beginning, it was just a very interesting concept, and I had become aware of it because I had seen a presentation that Carbon Cure had made at a Bloomberg event, and I found it very interesting, but hadn't really thought about the application locally in the village. And after conversations with Chris, we've known each other for 100 years. So we talk about many different things, but concrete came up. It became clear that there were a number of different reasons why, as a municipality, it made sense. And I was very attracted to the importance from an impact point of view of this particular action for our municipality, given the high percentage of CO2 generated through concrete, we could see that very basic projects that our municipality did could really be shifted in terms of that impact if we were using a substance that had less negative effect on the environment. So there was the environmental aspect. We also learned that it didn't need to cost that much more, or could cost an equivalent amount, and was something that we could do. And the other thing that we learned, which we hadn't really thought about, is that concrete is something that you procure very locally. So we realized that there could be a kind of ripple effect in terms of influencing the choices of other municipalities, particularly given that so many of us procure goods like this together. So it wouldn't just be Hastings moving forward, but it could be all of the river towns or multiple municipalities in Westchester or the state. So we established the rationale for those of us who were in the decision-making group. And the other thing that we did with the support of Chris, the Open Air Collective, and just research that we were doing ourselves was gathering and really evaluating policies from elsewhere. Matt showed a slide a little bit earlier of the other entities, some of them counties, some of them cities, some of them states in other parts of the US that were doing this kind of work, that were interested in concrete and that had pulled together resolutions. And so I think any of you who are involved in local government know that the creation of a resolution is a bit of a cannibalistic activity. You take a bit from here and you take a bit from there, the things that you like, and you try and create something that improves on what the others have put together. And we think that we actually crafted something new and unique. And a couple of the components that I'm particularly proud of was that our resolution applies to all building in the village. It's not just a building that relates to the municipal projects. So that kind of breadth was something that we thought was interesting and different. Most of the others only related to the municipal entity itself. The other thing that we included was a specific component about knowledge transfer. So normally resolutions only deal with the municipality and the impact on the municipality, but what we added at the end of our resolution was a charge to ourselves that we would spread this knowledge to sister municipalities and to other entities that might be interested. And actually the three of us, I think one of you said this, but the three of us have spent quite a lot of time giving these kinds of presentations in other places, which has made that part of the resolution come to fruition. The other thing I'll add is that one thing I do think is new is that we identified several different ways in which the idea of low embodied carbon concrete might be achieved in terms of methods and processes. So we talked about using less cement in concrete mixes. Matt referred to that, replacing or substituting cement with other types of materials such as fly ash or slag or ground glass pozzolan, which we're all very excited about, using locally produced cement components, because that means that the transportation component will be lower, and then using mineralization of carbon in concrete materials, which is the carbon cure solution. So we wanted to give people a range of different ways in which they might be able to achieve this goal. And we conducted many different education-oriented activities. We set up a web page, we held webinars, we gave many speeches, most of them by Zoom because this was in the throes of COVID. And we also answered questions and participated in media type interest in this. But maybe the most important thing was just educating and getting buy-in from the key stakeholders. And so by that, I mean both the Board of Trustees and village, the high levels of village government, the village manager, but also our building inspector, our engineer, and other people, local architects, local contractors, people who were really going to be implementing this resolution. We wanted to make sure that everyone understood it, that they had their questions answered, and that we could explain what we were asking them to do in terms that made sense to them. So I think Chris and I started talking about this in maybe January of 2020, something like that. And we had a finally drafted and adopted resolution by May, which for those of you in local government, you know, that's like flying Concorde. That's one of the fastest adoption rates that one might have. So we were very, very pleased with that. Maybe Matt, slip to the next slide. So here are some examples of projects that we have actually implemented. So the first relates to a retaining wall, which is on a street called with the name Cliff Street. So you can see it's a pretty seriously important wall, and it got destroyed because a truck lost its brakes and actually hit it, and thank goodness no one was hurt. But we decided to rebuild the wall using low embodied carbon concrete, and in that case it was a fly ash mix that was used, and the wall looks gorgeous. No one can tell the difference. It's not green, despite Matt's slides, and it worked very, very well. And it was the project we used to test both whether we could explain this concept to our engineer, who was ultimately responsible and was the one who was accountable for safety issues, durability, all of those kinds of concerns, as well as to the contractor who needed to procure this product. And as soon as they understood what it was very, very easy for them. So rather than using 20% fly ash, they used 40% fly ash. So it's a pretty easy thing to explain. The second project was a retaining wall inside a pocket park, which everyone loves. It's right next to the village's favorite coffee shop. And the park the wall was kind of crumbling and needed to be repaired. And so again, we used low embodied carbon concrete for that project. The elementary school is actually a separate municipal entity. It's not the village, but we encouraged the architect, who happened to be chair of our zoning board, to look into this idea of low embodied carbon concrete. And he included those in the specs, and the extension project was completed using low embodied carbon concrete. That was about a $20 million project. So we were really, really excited when we learned that had happened. And that was voluntary. They weren't required to do that, but we were really thrilled. And then the final project, which is the one that I think we're all most excited about, is a downtown sidewalk replacement project. So we were given a series of grants, and I should say the first project was the result of an insurance. It was paid through by insurance. So in terms of risk that Matt was talking about earlier, there was no risk to us, although it dealt with a risk mitigation effort. The second was through a bond. The elementary school project was funded by a school bond, and the downtown sidewalk replacement project was funded through community block development grants. And we ended up getting a whole series of them. Many of the sidewalks in the downtown have been grantees from that. And so it'll at the end of the day, it'll probably end up being about $5 million worth of sidewalk that will be replaced using low embodied carbon concrete. So we're really excited about that. And that's the one we hope everyone will replicate. We hope all our fellow municipal leaders will think about doing sidewalks in this same way. So these are some of the success factors in our view. So we were technology agnostic, as I explained earlier. We included in our resolution a range of different methods and purposes. Myself and the board of trustees, and Trustee Lambert I see is on the call, and we have a climate smart communities task force that was supportive of this effort. One of the people who was in the Open Air Collective ended up joining our task force. That was a very exciting connection that Chris made for us. And so Eon was very involved in the leadership. Spencer, who is on the call as well, was very involved. Many different groups that play leadership role in terms of policy and in terms of guiding implementation were on board, which made it much, much easier for us to move this forward. And we were willing to absorb the risk. We started with all of the projects we've done to date have not involved significant cost to the village. And we were willing to experiment in a way which we felt was responsible. The other thing that we did was we spent a lot of time investing in knowledge transfer to all the different people who are going to have to play a role, and that paid off in our opinion. And we made this commitment to inform and educate other municipalities, and many of them have both passed resolutions of their own as well as started to implement projects that are similar. So it involved a lot of engagement, it involved teamwork, it involved honing our message. We explained things in a bit of a complicated way in the beginning, and the message has become clearer. Having Matt be able to speak to the engineers and contractors makes a big difference, and having Chris take the resolution and use it to influence Albany was really, really exciting. It's very, very exciting to see that this little tiny resolution from this little tiny village of 8,500 has been instrumental in some of the work in the community. So thanks to both of you for that. And I think the next slide is the last slide. So I don't know if there are any questions.
I actually have one. I'm curious what you found. Was there any holdouts from the town board or any stakeholders around Hastings that were resistant to that? And how did you convince them otherwise?
So we didn't have any holdouts on the board. Everyone on the board was enthusiastic. What we found was that you had to explain the concept to people, to our engineer, to the contractors. Once people understood what was involved and the different ways in which you could achieve a low embodied carbon concrete outcome, we were able to convince people. So that was my takeaway. It really was all about educating people.
Yeah, and I just to add to that too is I think it's with good reason that there's a lot of caution among folks who are looking at this. I mean, we're talking about the material that literally is the foundation of modern built environment, and you have to get it right. You can't cut corners, and so the fact that there's a lot of caution and thoroughness is a good thing, and so. But you just got to be patient and move through that and make sure that we're answering questions in a really data-driven way. And so it was a great process. Having folks like Matt join us who could really speak from a position of real authority was critical. But I wanted to mention too is that this small great group that we have listening in. I'm excited. Melissa Everett from Sustainable Hudson Valley is on, and we were just messaging, and she was interested in which other local communities are. We've spoken to, and I've been with you, Mayor Armacost, with some of the river towns. I know Dobbs and Ardsley have both been looking at this across the river, but it's groups like Sustainable Hudson Valley. I know through your own work, Melissa, that you're all about creating networks and sort of spreading best practices. So Really glad you could join us, and it would be exciting to see how we could bring this outside of the Rivertown loop and see if we can push it.
We've been working, I will say, on, and you helped with a regional climate action strategy, and we are doggedly turning that into a really actionable web published thing that's going to have a little roadmap, like timeline, tactics that are possible, reference case studies, etc. So it's going to be out there.
Yeah, I mean, to add on, I think one of the things that's exciting that we're able to demonstrate in the river towns is this idea of aggregating our purchasing power. So we do that already for roads. We do it for various other things. We have these intermunicipal agreements, and as soon as other mayors understand the impact of this, many of them are enthusiastic, and so we've been able to. I think Ardsley has passed a resolution. I'm pretty sure Dobbs Ferry also passed a resolution, and I know that there are other municipalities further up the Hudson River. I think Nyack passed a resolution or wants to pass a resolution. So there are a bunch of others, and there are others who are not bothering to pass a resolution. They're just shifting their purchasing practices. And the other thing I wanted to sort of add on to Chris's point about the idea of being cautious and de-risking. The projects we've started with, we didn't start with a bridge project where everyone would be very freaked out about the use. We started with projects where standing on sidewalks is very different than driving an articulated lorry across a bridge. So we started with projects which residents will be able to understand they're less risky, just inherently less risky, because the safety issues, the durability issues, they don't create public safety concerns in the same way as a bridge project might, or a 30-tower building might. So it was very exciting actually to see that the school decided to use that in its project, because that actually is sort of moving into the place that all the projects need to end up in. So anyway, we're pretty excited.
If I could just say one thing, Nikki, I'm surprised how we referenced ground glass Poznan a little bit, but that is definitely worth people really looking at here, because it's a super interesting opportunity for this area, because there is a major sort of nationally leading provider that's based right in Westchester County that can serve the whole tri-state area. And as Matt said, there's these shortages of these other substitution materials that things like ground glass Poznan on a local level can really start to fill those gaps. So hopefully that's something through our efforts we can really promote and realize here in the Hudson Valley and New York State. We're
very excited. Our engineer has spent quite a lot of time on it. And we're hoping that in some upcoming sidewalk projects that go in other directions in the village, one that goes up near to the pool, we can experiment with ground glass Poznan. And I'm actually very excited to see if we can do a project that involves the carbon cure methodology at some point, but that technology is a little bit further away. But the thing that's so wonderful about ground glass Poznan is that we would be using glass that would be coming from a recycling center, which is 5 minutes away from where we live in Yonkers. The recycling center is very, very close to us. So that would be as local, I think, as it gets in terms of the source. So we would all be delighted if that becomes more available. Thank you, Melissa. Very special thanks to you, Melissa, and to Ben and to Isabel for having us. It was really great to be there. And
thank you so much.
Great.
Thank you.
Thanks, everyone.
Thank you all.
Take care. Bye.
Bye.